Hi everyone, welcome again to the differential equation. So in this video, we will look at the properties of the Laplace transform, which is the first properties that we will want to investigate here, is the linearity of the Laplace transform. What is the linearity of the Laplace transform? So we can look at here, the Laplace transform is a linear operation that's for a function of ft and gt whose transform exists and any constant of a and b. The transform of the function of t and the function of b exists, and if we have the Laplace transform of a, the function of t, plus b, function of t in here. So the solution of the Laplace transform is a is constant, so we can put a outside. So a, the Laplace of ft, this one is equal, plus b, Laplace transform of gt. So we got this one. I just keep here. Basically, you can try by put step by step, which is that we multiply by the function by the est as the definition, and then you solve the integration from 0 to infinity. At the end, you got this one. So to better understanding how the linearity of the Laplace transform, let we look at the examples of these cases. So the question is, find the Laplace transform of that function. They give the ft is equal to 5t power of 3 plus 6t power of 2 and 3t. And then we can write down this one as the Laplace transform of ft is equal to the Laplace transform of, okay, this one is the function. We got the ft is 5t power of 3 plus 6t power of 2 plus 3t. And then we can spread, we can say we put the each the function in their own Laplace transform like this. So this one 5, basically you have the step here. Maybe we can put the Laplace transform of 5t power of 3 plus Laplace of 6t power of 2 plus plus Laplace 3t, like that. And then as this definition, we get the function, we can put outside the Laplace. So here we got 5 Laplace of t to the power of 3 plus 6 Laplace of t to the power of 2 plus 3 Laplace of t. Then we look at back the properties of the Laplace here. For this one, if we got the Laplace of the function of t, so the Laplace transform of function of t is n factorial over s n power of 1, which is that depend on this value of n. So okay, so here this one 5, I write down back here Laplace transform of t to the power of n is equal to n factorial over s n plus 1. So this one 5 t to the power of 3, meaning that 3 factorial over s 3 plus 1 plus 6 2 factorial over s 2 plus 1 plus 3 1 factorial over s 1 plus 1. So the end, we got 5. 3 factorial is 6 over s to the power of 4 plus 6. 2 factorial is 2 over s to the power of 3 plus 3 1 to the power of s squared. The end, this is the solution. 5 times 6 for the Laplace transform. So that's what we call the linearity of the Laplace transform, which is that we can solve one by one from the function given. What else? So here, this one is the proof of how the Laplace transform of cosine, we got this one, and Laplace transform of sine, we got this one. This one you can refer to the summary in the previous video or in the previous slide that we got the summary of Laplace transform cosine, Laplace transform of sinus. Got this one, and then we can apply here. Okay, combined function. So we have here the function of exponential and the function of sine hyperbolic here. Again, by linearity, meaning that we can solve one by one. So from here, which is that from here we can write down like here, which is that one by one, the Laplace transform of e to the power of t plus Laplace transform of sine hyperbolic 2t. Okay, so we solve one by one here. So the Laplace transform of e to the power of t, we got 1 over s minus 1, and then for the Laplace transform of sine hyperbolic 2t, we got 2 over s squared minus 2 squared actually. So from here, just simplify, you can get this one. How from here to get here, how from here to get here, you can refer back to the summary of table that we already discussed in the previous video. And then for the inverse Laplace, let we look at this one. I use the blank sheet, but before I'm explain about this inverse Laplace, basically as we look at here, basically this one is equal to Fs. So when we got the Fs, we need to solve this Laplace transform. We need to inverse back the Laplace transform to be in the function of t again, because here is the function of s. So we go to the example. This one we have here, basically they already transformed the function into this Laplace transform. That's why you can get here the function of s here, not the function of t anymore. Okay, so let I use the blank sheet like this, so that easy to we look at one by one or step by step. So where's the pen here? Using the blue color. We have the Laplace transform f. Sorry again. Okay. Fs equal to s plus 7 over s squared minus 3s minus 10. Okay, so we can simplify this one, become s plus 7 over s plus 2 s minus 5. So we factorial this one, and then from here we can use what we call the partial fraction. Okay, so from the partial fraction, basically from s plus 7 over s plus 2 s minus 5, this one we can write down as a over s plus 2 plus b s plus s minus 5. Then we compare the denominator. Here we got s plus 7 is equal to, so basically this one we can multiply at the bottom so that we have the similar as this one. So here we got a s minus 5 plus b s plus 2 over s plus 2 s minus 5. So we got this one is similar to this one. Since the bottom is similar, we just consider the denominator. Okay, s plus 7 is equal to a s minus 5 plus b s plus 2. So what we need to determine right now is what is the value of a and b. So the numerator of s is 5 and 2, because here let's say s equal to 5, so we got this one s 5 plus 7 is equal to a s minus f is 5 minus 5 plus b 5 plus 2. So this one is cancelled. So 12 is equal to b 7b. So we got b equal to 12 over 7. Again, let me put s is equal to minus 2. So we got 2 plus 7. The minus 2 plus 7 is equal to a minus 2 minus 5 plus b is b is 0. Okay, because minus 2. So from here basically you can refer to the slide. We got a equal to minus 5 over 7. So what we need, actually we need to determine b and a, because we want to substitute into this one. So when we got the value of a and b, we substitute to this one. So at the end we got, as you can refer back in the slide, which is okay, down here, sorry again. So we have fs is equal to minus 5 over 7 over s plus 2 plus 12 over 9 over 7 over 7 over s minus 5. So by concept of linearity, meaning that we can solve this one by one, which is that the minus, I write down in better way, try to use maybe little bit thickness. inverse Laplace, again, inverse Laplace of fs is equal to inverse Laplace of minus 5 over 7 over s plus 2 plus inverse Laplace of 12 over 7 over s minus 5. When we have in this kind of form, again we refer to the table. We refer to table. How this one maybe okay. I try to go to back to this table. Okay, basically we are here. We are in this form, which is that fs. So we need to change from fs to this one. So we check which the pattern of this fs is similar to what we got, and then we just transform into the ft again. So if we refer to our case, we got minus, okay, maybe this one can write down as, because this is the constant, so we can put in front of the Laplace inverse. Minus 5 over 7 inverse Laplace of 1 over s plus 2 plus, this one is 12 over 7 inverse Laplace of 1 over s minus 5. So if we compare, this one is similar to this one actually. So this one, because we have 1 over s and the constant. So if you have 1 over s minus a, so the inverse Laplace is will become e to the power of a t. So this a is this one. So we go back to our slide. So we have here this one. Again, maybe I can write down where here. So e to the power of a t is not in this form. Basically, Laplace of e to the power of a t is equal to 1 over s minus a. So plus a again. Check back the s minus a. Minus a here. So if we inverse Laplace 1 minus s, 1 over s minus a, we got e to the power of a t. So here a is 2, a is minus 2. This one a is 5. So straight we can obtain the result for this one, which is that we got minus 5 over 7 e to the power of minus 2t plus 12 over 7 e to the power of 5t. So similar as we got in the slide. Where is it? Okay. So here the step that you can refer. At the end, we got the solution of the inverse Laplace as this one. Basically, this one is in terms of function t again, when we inverse Laplace the Laplace transform. So that's all. Let's take a break, and you can take your time to look at step by step and try to understand. And please do not hesitate to put your comment or put your question in the chat box so we can discuss if something that you do not understand. Okay, meet you again in another